This is the rover final product. So the problem definition is, in this project, we will design a rover that performs well in competition while following all given guidelines, as well as making the most cost-effective decisions in order to stay within the right target budget. The design requirements, after moving to the online class, it changed into more of a toy car-like model. So it didn't need to be driven by a motor, but it still had to be mobile, as this model is. The conceptual design, originally, I had 3 wheels per side. As you can see here, I decided to take off the middle ones right here, because I realized that it caused excess friction that was not necessary, as you can see in this model right here. And then this is the model that was I made, and these stability wheels were not necessary, so I decided to take them out. Here is my design for the circuit board that I would have had on my rover. As you can see, I have 4 motors, 1 for each wheel, and I could have added a potentiometer in one of these lines, but I figured it wasn't necessary because this would be moving at a constant rate, so there wouldn't be any need for any change in speed, and also I wouldn't be allowed to tamper with the model while it is moving. So here is the layout, and then this is my code. As you can see, it's pretty simple. I just defined the 2 different sections. So motor 1 is going to be 8, and then motor 2 is 12. And then I would just have this loop. Both of the motors would be on high, and I would just delay them for 1,000. All in all, it was a pretty simple design, and I decided to define only 2 motors. So this motor, the electrical current goes all the way through this one and this one, because they would both be driving at the same speed, so I didn't figure it was necessary to actually make 4 different motors. So in my original design here, I had no axles, and I realized that the most effective way to give this car more stability is to give them axles. This also gave them the ability to have a drive shaft. So here you can see, as I twist this up, it charges potential energy, and then once I let go, it starts to spin. Now when you have an axle, you want to have the least amount of friction right in between the pencil and this hole right here. So with that, this is what I did my testing on. I compared 4 different types of axles. The first one was what I started off with, just your basic pencil right here. This wasn't ideal, I figured, because of the hexagonal shape on the pencil. The next is just a pen casing. And then the next one is a colored pencil, which has a circular profile. And then the last one is metal wire. This is a little bit flimsy, so I didn't expect it to work as well as one of the other pencils, but I figured that I should try it just in case. Now, the data that I came up with actually favored the colored pencil because of the smoothness and its rigidity. If I did have a thicker version of this wire, I would expect it to actually be a little bit better. But since I didn't have a metal rod or anything like that, this colored pencil did the best, so I decided to use it in my final design. So I'm going to point out a couple key components here of this rover. So first you have the chassis. This is the main body, and these are the wheels. This is the front wheel. This is the back wheel. The front wheel is being driven by the rover band, and it is attached to this larger section right here so that we can add a little bit more torque onto the rover. And these are the legs that suspend. I did have the third pair of wheels in the middle here for stability, but I took them off due to increase in friction. Overall, I thought this whole experience was very helpful in my understanding of the engineering process, and I'm very happy with how my product turned out.